Hello students, I hope you're doing well today. We are working with Lab 2.2. This is on inductors. You have two components in this circuit, 120 millihenries and you have 2.2 k ohm right here. So what we're looking at here for a circuit, we're going to apply 6 volts and my frequency is 2000 hertz. So you can see that right here. So I've built my circuit here for your learning pleasure. So let's take a look here. I've got my inductor here. I've got my inductor and my resistor there. And then as you can see, I've got my input voltage dialed in at about 6 volts. So here's what we're looking at here. So we need basically on this lab, we're taking 2 readings. We're taking we're of course going to take our components, going to measure the value of the resistor as well as the inductor. The RW is the resistance of the winding. We want to make sure we test that winding just to make sure that that inductor is a good inductor. Then we're going to fill out this chart. You can look at the measured values we're going to have. Our total voltage is what we're going to dial in. As our 6 volts, 6 volts RMS, we're using our digital meter for that. And then we're going to take the drops for voltage on the inductor and resistor, and then we'll also measure current. So let's take a look at that. Here's how we're going to do that. So look now as I've got my my leads for my circuit is right here. So as you see, I'm looking at my load circuit here. Move this over so we see everything. So there's my load circuit. I've got 6 volts dialed in. I want to measure the voltage on the inductor. Look at that there. I'm getting close to a little bit over 3 volts at 3.2, and then I'm going to measure the voltage on the resistor, my load resistor here. And that's going to be close to anywhere from 4.5 to 5 volts, somewhere along in between there. Okay, so those are my 2 voltages or 2 voltage drops after I do my input. And there's one other measurement that we're going to do in this experiment, and that is current. And remember how we measure current is we set our meter to measure current. So we move our red lead over to the correct position physically, and then in this case I calculated about I think around a little over 2 milliamps. So what we do when we're measuring current in series is we disconnect our circuit on one end. So I'm going to disconnect the ground, put the 2 grounds together, and then the circuit is going to be between the 2 red leads. So let me pull all these other ones out so you can see what I'm doing here. And so now you see the devices are between the 2 red leads, power supply and meter, and the 2 negatives are together. We're measuring current, and my current, I'm not sure my current meter is working. Let me swap this out and see, but my current in this case should be a little over 2 milliamps, about 2.3 milliamps. Let's see what I got here. And this meter's not working either, but you should get about a little over 2 milliamps. So that is the just the measurements there. That shouldn't take you too long to set up. Now what we're going to do here is, I'll show you this in just a second. We'll have to do some of the equations. So you're filling out this middle part, okay? So we got we got a measurement here, a measurement here, a measurement here, a measurement here. These calculations we do are going to be below here. So let's take a look at those calculations. These are my readings here. I measured 6 volts is what I applied. A little over 3 volts for my inductor. About 4.6 volts for my resistor, and my current came out a little bit over 2. These are the calculated values, and I got those from these down here. Okay, so let's look at the top. Here's the equations we're using. We're figuring out the inductive reactance. So I just use the formula 2 pi times 2,000 or 2k hertz times my measured inductance, which is 120.4 millihenries. You should be right there, and you should come up with about 1.5 k ohms. Then we're going to do use Pythagorean theorem, and this is going to be calculating our total impedance, which is Z. So take the square root of R squared plus X squared, and in that case I get about 2.64 kilohertz. So I'm going to be using these two values here. Now I'm measuring current. My total applied voltage was 6 volts RMS. I take my ZT from up here, goes here. Figure out my current's 2.25. I measured 2.1 and I calculated 2.2, so I'm in the ballpark. I'm pretty happy with that. And then we're looking at voltage for L1. So I take the current I measured here, I multiply it by the X of L, which I calculated here. So this X of L times this current is equal to the voltage drop we should expect on X of L. I measured 3.2 and I calculated 3.4. I'm happy with that answer. And then again, we're using just Ohm's law again to measure voltage drop on the resistor, and it comes out very close to what I measured. Now let's take a look at this next page, okay? So the next page is I've got a couple of deals, and we'll spend some time next time on figuring out how these charts work, okay? I'm going to do some trig the next time we meet next week, and I'll spend some more time on that. So take a look at these questions and see what you can do as far as information on there, and this should give you just a quick overview, and you should be able to do this lab. So if you're not able to do the experiment beforehand, take a look at this video and go ahead and fill your information out here, and we'll do a review when you get back to class. Stay safe and curious.